Today, we're going to get this shabby looking golf cart to move again with our petroleum based battery system. In other words, we're going to provide proof of concept that this novel idea will in fact restore the functionality of the electric golf cart by replacing its conventional batteries with an electromechanical power source. So that's right, I said petroleum-based battery. At least that's what we're calling it. Now go ahead and grab a beverage, pull up a chair, and join us for our shenanigans. So instead of replacing the 6 heavy and expensive batteries, plus rebuilding the outdated electrical system on this antique Cushman electric golf cart, we're going to install a 212cc Predator engine that will be connected to an automotive type alternator, and that will provide nearly all the electricity this cart will need to get moving again. Now, we're calling this concept the petroleum battery because, well, it operates on petroleum and makes electricity. Now, judging from the many comments I got on the previous video, a large number of folks correctly identified the system that we're building is actually the same as what's used on a diesel-electric locomotive, except ours uses a gasoline engine. Anyway, as you can see in this simplified diagram, a diesel-electric locomotive has an engine, an alternator, and traction motors. There are no batteries except for the one that's used to start the diesel engine. Now on our golf cart, we're basically building the same thing, and we don't need any batteries or capacitors to power our electric motor. However, we will need a small battery to power the electronics. Now, as I mentioned in the previous video and a few moments ago, the whole purpose of this project is to eliminate the heavy and expensive lead-acid batteries, and we'll generate the electricity that we need with our petroleum battery. Now, of course, there is a loss of efficiency when converting from mechanical energy into electrical energy, and then converting that electrical energy back into mechanical energy. I'm aware of that. After all, golf carts were never made to be efficient. They're just neighborhood cruisers, and some people actually use them to play golf. And just to be clear, a diesel-electric locomotive uses the system not because it's fuel efficient. Nope. The main reason is this system provides a way to couple the powerful diesel engine to the wheels without using a transmission or a clutch. So this Cushman golf cart was cheap because it's in poor condition. To me, it makes perfect sense to experiment on this golf cart because we'll likely need to modify a lot of things as we develop the petroleum battery concept. So cutting and welding on this cart won't affect its resale value, well, because it's really not worth more than a few bucks anyways. If things work out, perhaps down the road we can transfer this system to something that's in better condition. But for now, this shabby cart will be perfect for our experiments. So power washing this cart really didn't help with the way it looks, but we did wash away a lot of dust and dirt. I reckon this is as good as it's going to get. So the alternator that we're using is something that we already had in stock, and it's from a Jeep Liberty. It's rated at 140 amps, and I believe that may be the limit of the diodes that are built into the alternator. We're going to be using the original diodes initially, but we do have a set of better diodes in case these stock diodes fail. Now, our plan to get more power from this alternator is to eliminate the voltage regulator and supply the electromagnetic rotor which is inside the alternator with significantly more voltage than it was designed for. In effect, we'll be overdriving the alternator to exploit the fact that it can produce way more voltage and current than it was rated for. Now, this thingy is the voltage regulator and brush assembly, and unfortunately on this alternator, the brushes are bolted to the voltage regulator, and we can't totally get rid of the regulator because, well, the brushes would have nothing to hold them in place. So, we're going to have to disable the voltage regulator and leave that in place. Now, I did do some poking around off camera, and I discovered the output side of the alternator is connected to whatever's inside this regulator by this calibration resistor. So, we're going to cut this resistor out of the circuit, and that'll disable the regulator. Keep in mind, all alternators are different, and we got lucky that this one's easy to modify. The ideal solution is to completely remove the regulator, but in our case that's not possible. So the goal in modifying this or any other alternator is to be able to inject an external voltage to the brushes so we can provide the rotor with a stronger signal, and that'll raise the output voltage of the alternator. Now, since we're overdriving the voltage to the rotor, the good news is we don't have any trade-offs and we'll be able to keep the 140 amp rating of this alternator. And it actually might make more, but we'll probably blow up the diodes. Anyway, blowing up the diodes is not ideal, but that's fine. If we break something, well, we'll certainly know the limits of what this thing can take. So typically an electric golf cart has what is known as a motor controller. At least on the modern carts, older carts use a bunch of relays to control the voltage and current to the electric motor. On this project, we're going to dual purpose the alternator and use it as a device to generate electricity, and we're going to use it as a motor controller. Now don't be afraid of what I'm saying. What we're going to be doing is super simple and there's no reason to panic. Anyway, with the regulator disabled, all we need to do now is add 2 wires to the brush holder so we can send power to the brushes, and in turn the brushes will energize the rotor to create a bigger magnetic field and create the power we need to feed the electric motor on the golf cart. Technically, we only need 1 wire, which is the hot lead to one of the brushes. You see the other brush is grounded to the case of the alternator. Today, I'm going to use 2 wires, one for the hot side, and the other one's going to be grounded to the case on the alternator. The reason is, this makes it simple later on when I wire in a gizmo to control the voltage on the rotor. So this purple wire is going to the hot side on the brushes, but there isn't enough room to safely connect it. So I'm going to use a spacer and a longer screw to raise the connection point, and that way I don't risk shorting anything out. Blah, 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 I know, too many words. Anyway, here's what's going on. This is the rotor and it's the thingy that spins inside the alternator. Over here are what's called the slip rings, and these are how the brushes make contact with the rotor. The brushes and the slip rings are what makes it possible to send voltage to the spinny thing inside the alternator. Now, what I just did was disable the voltage regulator and connected a pair of wires to the brushes, just like this. That way, I can supply the rotor with power from this guy. Now, this thing is a $12 DC to DC PWM voltage source. This adjustable voltage source can supply anywhere from 0 to 12 volts to the rotor. For example, at 0 volts, well, the alternator won't make any power because this spinny rotor doesn't have a magnetic field being generated. However, as we increase the voltage by turning this knob, well, it'll increase the voltage to the rotor and cause a magnetic field to develop, and the alternator will start producing electricity. This is the basic principle on how alternators work. Anyway, the voltage and the current from this little power supply is tiny. However, the voltage and current the alternator will produce is massive. So earlier when I said we're dual purposing the alternator and we'll be using it as a power source for the electric motor and we'll be using it as a motor controller, well, this is how it's going to work. It's simple and sweet, and the only battery required is this little guy to power this thing. With this setup, we'll be able to soft start the electric motor in the golf cart, and that'll prevent any current surges. So there's actually no need for heavy-duty batteries or capacitors in the system. Sound good? Well, let's make it happen. So right away we have a problem, and we need to figure out a way to mount this alternator without putting in too much effort or spending any money. So after searching through my stash of stuff that I'll never use, I came across these bearings. Now I did check, and a set of these bearings sell for like $15 on the Jungle site. So given the fact that I'll never use these for anything in the future, well, these will make a perfect mounting base. Now I did some more scrounging around, and I found a reducer bushing that converts the 1/2 inch inside diameter of the bearing to approximately 3/8 in diameter. Bushings like this are also available on the Jungle site for a few bucks. So overall, we have a decent mounting base that required 0 effort and was more or less free. But if I did have to spend money, it would be less than a $20 bill to purchase these parts. So the next thing we need is a pulley that we can mount on the Predator engine. Now this gets a bit complicated because the pulley we'll need is for a serpentine belt. And once again, I found a pulley in my junk pile, and I believe this pulley is for a Ford water pump. So the pulley does look like it'll work, but we'll need to weld a hub onto the pulley. Now this hub has the right inside diameter for a 3/4 inch shaft, but the flange is way too big. I think this flange is a disc brake hub for a go-kart, and they're available on the Jungle site. But like I said, this flange is way too big. So fast forward about an hour and I went ahead and machined this flange down on the lathe. Now things are looking a lot better. So in order to weld these two items together and keep everything centered, I 3D printed a spacer that'll keep the parts centered. Now the plan is to install the spacer, then tack weld the parts, and then remove the spacer before it melts. Using the 3D printer to make this precision spacer is an awesome cheat, but I reckon I could have centered the two parts a different way if I had to. This bolt will hold these parts firmly together. Now, the washer is way too big and it may look like stuff is not centered, but that's just a washer, so no worries. And this is the finished pulley. Not too shabby, and I think it'll work just fine. So off camera, I made some modifications to the Cushman. Now over here, I went ahead and cut a hole into the side for better ventilation. I'm not sure we need this, but it can't hurt. Now up front, I cut another hole for the pull cord on the petroleum battery. I'll go ahead and 3D print something that'll fill this hole in a little bit better once the engine's installed. I reckon all we need to do now is to assemble the petroleum battery, and we can see if this will actually work. So this area here used to hold 3 very large and heavy conventional batteries. Now it's the perfect spot to put our petroleum battery. So for the base, we're going to use this chunk of 3/4 inch plywood, and as you can see, I've already marked the locations for all the mounting holes. Now this will lock into the battery tray like this. Now plywood isn't necessarily the best mounting surface, so we're going to put a layer of aluminum on top of it. Off camera, I went ahead and fabricated this mounting plate, and it'll certainly add a lot of strength to our system. Okay, well, pretty much all the details have been worked out as far as fitment and mounting stuff. Let's go ahead and assemble all the components. The alternator adjustment bracket turned out to be a complex problem, and I had to fabricate this interesting gizmo in order to get stuff to line up. Now this turnbuckle is yet another part from my stash, and I believe it's an alternator adjustment thingy for a V8 engine and some sort of Chrysler product. Basically everything I'm using today, including the engine, is junk from my stash. The engine is actually brand new and it was purchased 4 years ago, and it's truly a $99 engine from Harbor Freight. This project is extremely low budget, and if I don't have to spend money on it, well, I won't. And that makes my accountant happier. Alright, that's pretty much it. Now, to adjust the belt, all we have to do is spin the turnbuckle and we can add tension to the belt. You know, this thing looks too pretty to put in the Cushman. The good news is, the belt and a few bolts were the only things I had to purchase. So far this project has cost me just over $100, but if you factor in the stuff I didn't have to purchase, well, we're closer to $400, which is still cheaper than buying new batteries for the golf cart. Now on this petroleum battery, we have to pre-charge it, and to do that we need to fill the internals with a medium weight petroleum product. This is an important step in getting the petroleum battery ready for use for the first time. Alright, the pre-charge is done and we won't ever have to deal with that again. Time to drop this into the cart and see how it fits. So this thing is about 45 pounds, which is fairly light, and as I recall the batteries weighed 54 pounds each and we had 6 of them, so this new system reduces the overall weight of the cart significantly. Ah yes, it fits like a glove. Of course we still have to install 2 heavy gauge wires that go from the alternator to the electric motor. Now over here you can see the 3D printed thingy for the pull starter. We printed it in red to alert people that pulling this starter handle can cause the petroleum battery to activate unexpectedly. Sort of a safety thing. Now this side vent seems to provide adequate ventilation so the engine can get fresh air to keep cool. I'm not sure how important that is because, well, I don't think the engine's going to be working too hard. And finally, all the way down here is the terminal on the alternator that gets connected directly to the armature stud on the electric motor. We'll also need to pull a ground cable that goes from one of the grounds on the alternator to the big DC motor. Then we can fire this puppy up. Oops, I almost forgot. On this petroleum battery vehicle, we need to add a vent tube to allow the hot and dangerous gases to escape this compartment, sort of like an exhaust pipe on a conventional car. And now we can charge the petroleum battery. We'll be using an off-the-grid charger today, but generally speaking, this petroleum battery can be recharged wherever petroleum products are dispensed. And the best part is, recharging this only takes a few seconds. Fast forward a few hours and we've made some progress. Now, for safety reasons, we've jacked the cart up to get the rear wheels off the ground because this thing actually might move. As far as the wiring goes, we've attached some heavy gauge welding cable from the output of the alternator to a terminal on the series wound DC motor. Now the other wire is grounded to the alternator, but instead of attaching it directly to the motor, we've temporarily routed it to this current shunt. This shunt is how we're going to measure the amps that the DC motor is consuming. The way this shunt works is, there's a slight resistance across it and it actually measures the voltage drop. And we can see the voltage drop on the fluke meter by monitoring how many millivolts are being displayed. For this shunt, a 100 millivolt voltage drop translates to 100 amps. You know, a lot of people were confused in the previous video when they saw that I was measuring the motor current in millivolts. Well, that's because we're using a current shunt. Now over here we have two meters. This guy will be measuring the voltage from the alternator, and the fluke will be measuring the current that the big DC motor is consuming. Now down here we have a benchtop power supply, and I'm going to use this to inject voltage into the alternator. This power supply will allow us to see the current and the voltage we're supplying to the alternator, which I reckon won't be much. Now over here I did rig up a temporary throttle on the engine in case we need to speed the engine up. However, on this test, we're only going to run the engine at high idle. Everything is more or less safe for now. Normally I do a better job securing the cables and the wires and the whatnots. I say we fire this monster up and see what happens. Clear prop. Perhaps I need to choke it. There we go. Now this is concerning. It sounds like there's an exhaust leak. Yeah, I can feel it's leaking from the flange. I'll have to fix this later. You know, I was sort of expecting this petroleum battery to be a bit more quieter, but this'll be fine for now. The welded up pulley seems to be perfectly centered, so that's good. Alright, let's see what happens when I give the alternator a little bit of juice. Now I'm going to ramp the voltage up just a little bit, and I guess we'll have to watch the wheel. Perfect! We have excellent control of the wheel speed. So right now I'm not feeding much power into the alternator, and we have a positive reaction, so that's good. This is what I was talking about earlier when I said we were dual-purposing the alternator, and we're obviously using it to generate electricity, and we're also using it as a DC motor controller. And it looks like we have the ability to soft start the big DC motor, and that's awesome. Let me pull back on the voltage. Nice. So right now the alternator is only feeding 3 volts into the motor and it's drawing 23 amps. Let's crank it up. Oh hell yeah, she's chooching. Now the alternator is generating 32 volts and the motor is drawing almost 30 amps. There is of course no load on this DC motor with the wheels off the ground, and I reckon we'll draw a lot more current if the wheels were on the ground. Now the wheels are spinning pretty quick, but there's still a lot more power I can feed into this thing. However, I am concerned about overspeeding the electric motor. So right now we're only feeding the alternator 4.3 volts at 1.16 amps. Wow, that's pretty much nothing. And we're getting full speed from the DC motor. Of course, once again, that's with no load on the motor. So if I pull back on the alternator control voltage and let the wheels spin down, well, I don't get any regen type voltage from this series wound DC motor. You know, I kind of thought that would be the case because there's no power going to the fields. So what that means is, this electric motor won't make voltage for regenerating a conventional battery. But that's no big deal because we have a petroleum battery and it doesn't need a regen. I say we put this thing on the ground and tether it to the Renault. You know, French cars make great anchors. Alright, let's see what happens. Well, that's impressive. It pulls the Renault no problem. And we have very good control of the motor, which is also good news. Whoops, I ran out of wire. Let's try that again, and this time I'll get the meters in the shot. So far, so good. You know, we haven't even come close to the limits of the alternator, and we're already seeing excellent results as far as the motor control and the output of the alternator. Let's take this to the next level. Okay, we're still tethered to the Renault, but this time around I half-assed installed a battery, and we're going to use that to power the PWM power supply for the alternator. We're going to use this knob as the throttle for the DC electric motor. You know, this is all very sketchy because I don't have any safeties in place right now. We really should have an e-stop switch on this thing. Let's see if this works. Alright, let's activate the petroleum battery. So if I slowly turn this knob, that should get this cart going. And it does. That's outstanding. Now for some of you folks, keep in mind I have to do this in a series of steps. At each step we validate that the concept works, and at no point have I even gotten close to the full potential of this setup. I think the next step is to put the seat on the cart and take it for a ride. Alright, we've removed the safety tether and the golf cart's free to move. Now that may or may not be a good idea, but let's activate the petroleum battery and see what happens. Oh, I did add a warning decal to the side of this rolling death trap. Meh, who reads safety labels? Anyway, speaking about safety, I did add a kill switch to the electronic throttle in the event something goes wrong on the maiden voyage. This switch will shut off the power to the alternator if something fails and we lose control of the golf cart. I do plan on adding an e-stop switch, but not today. Today, I'm going to have a co-pilot help drive this golf cart. It'll be interesting to see how the cart performs with 2 people on board. So the job of the co-pilot is to operate the throttle and maintain some level of safety while I recklessly steer this contraption down the road. So right away I can tell the co-pilot's not comfortable with what's going on and he's being cautious. Because of that, well, the throttle response is a bit sluggish. I'm more of a full throttle kind of person. A quick look at the meters, and it looks like the alternator is making 39 volts and the current draw is a mere 44 amps. At this point, we're doing 12 to 13 miles per hour. So far, so good. Keep in mind, this is an electric golf cart and it was likely designed to have a max speed around 15 miles per hour on a good day. So we're definitely not going to be breaking any speed records today. But also keep in mind, this is an electric golf cart and it's hauling 2 adults down the road without any batteries. So now the exhaust leak really makes this thing sound like a lawnmower, and to be honest, it rides like a lawnmower. I think if this petroleum battery idea is to be successful, we have to make it a lot quieter. That may help with the overall feel of the golf cart. You know, since we removed the heavy batteries from this thing, the ride is probably a lot stiffer, and that would explain why this thing rides like crap. I also pumped the tires up to 25 psi. These tires, well, they've seen better days, and actually all 3 tires are different. I reckon this thing is a genuine hoopty as far as golf carts go. So far, the 140 amp alternator is holding up fine as far as cruising down the road goes. And once up to speed, we're staying in the 40 to 50 amp range, which is outstanding. But until I get a proper accelerator pedal set up, we won't know how this thing performs from 0 to cruising speed. Now, as far as proof of concept goes, well, I feel like the petroleum battery idea has proved successful and this project warrants further development. Of course, that's my opinion, and my opinion's based on having fun with goofy projects. What do you folks think? Click on the like button if you think we should continue with this project, and if you can, write a comment of why we should or should not continue. I'm interested in hearing from you folks on this golf cart project. Well, it's Saturday afternoon already, and I have to get this video uploaded to YouTube fairly soon. Thank you to all that have subscribed to the channel, and thanks to all the many patrons who have joined in supporting the channel. I had fun today, and I hope you did as well. I think that'll do it for today, and I'll see you next time. Until then.